Hi. So I came across this question in the sample question paper for class 12 CBSE for the year 2024-25. Let us take a look at the question. There are two cages of birds. Cage 1 contains 5 parrots and 1 owl. Cage 2 contains 6 parrots. One day, Arka forgot to lock both cages and two birds flew from cage 1 to cage 2 and two birds flew back from cage 2 to cage 1. We don't know which birds fly from cage 1 to cage 2 and which birds again we don't know fly from cage 2 to cage 1. So it could be both being parrots, or it could be one parrot and one owl, and also the bird that returns, it could be both parrots, or if an owl has already flown from cage 1 to cage 2, it could be an owl and a parrot together flying back to cage 1. So we don't know which birds fly, but what is given, the most important information is all birds have equal chances of flying, which means the probability of a parrot flying is the same as the probability of an owl, whereas the probability of a parrot flying here, because there are 5 parrots, it becomes 5 out of 6 in the first cage. And because the owl is less in number, the probability of an owl flying is 1 out of 6. We'll come to that in a bit. So we'll read the questions. On the basis of the above information, answer the following questions. When two birds flew from cage 1 to cage 2 and two birds flew back from cage 2 to cage 1, find the probability that the owl is still in cage 1. So in this question, the owl, they're asking for the probability of owl is in cage 1, which means the owl, either it flew from cage 1 to cage 2 and it flies back to cage 1, or it could be the owl did not fly at all. It already stayed in cage 1. So whenever we come across scenario 1 or scenario 2, we take them individually and solve it case by case. So I'm going to take case 1, where the probability, we're going to find the probability of the owl flying from cage 1 to cage 2 and cage 2 to cage 1. So since there are 6 birds in cage 1, we could consider the total sample space of that. It could be any 2 birds out of 6 flying from cage 1 to cage 2. So what I'm going to do is, this is for cage 1 to cage 2. And likewise, the total sample space for cage 1, that's 8C2. We don't know as of now, we're not finding the favorable outcomes. We're not trying to find what is the probability of owl flying. We're not doing that now. So what we are doing now is we're trying to find the number of ways any 2 birds can fly from cage 1 to cage 2 and likewise from cage 2 to cage 1. So 6C2 is the number of birds, 2 birds that fly from cage 1 to cage 2 out of 6 total birds. So 6C2 into, I'm going to multiply 6C2 into 8C2. That gives me the total number of possible ways any 2 birds can fly from C1 to C2 and C2 to C1. I'm multiplying. That's because the 2 birds that fly C1 to C2 is independent of which 2 birds fly from C2 to C1. These 2 are independent events. So we multiply the probabilities if the events are independent. So 6C2, so that will be 6 into 5 divided by 1 into 2 into 8 into 7 divided by 1 into 2. If you multiply, it becomes, so this is 3 and this is 4, so it becomes 15 times of 28. So the answer is 420. So this is the total number of possible ways any 2 birds fly from C1 to C2, C2 to C1. Now we are going to find the probability of owl flying. So number of favorable outcomes for owl to fly from C1 to C2, and likewise from C2 to C1, I'm going to find it for later. So N of F for owl from C1 to C2. See, it is not just the owl that flies from C1 to C2. It says, the question clearly says, there are two birds which fly, which means an owl along with some other, the other is what? The other is a parrot. So we are going to find an owl and a parrot flying from C1 to C2. So the probability of an owl, so there is just one owl. So there is no other way than taking one C1. There's just one owl, that owl flies. So whereas parrot, there are five parrots. So out of five parrots, I'm going to take one parrot to put into the other, to fly to the other cage. So since these two again are independent events, I'm multiplying them. So 1C1 is 1, 5C1 is 5. So this is for C1 to C2. Likewise, N of F for C2 to C1. That will be again owl and parrot. Remember, now that there are two birds extra in cage 2, the cage 2 has 8 birds to begin with before they fly. So owl is again 1C1, whereas now the parrots will be 7 in number. So that will be 7C1. If you multiply these two, you will get 7. Now I'm going to find the total favorable outcomes. Once again, I'm going to multiply 5 and 7. That's because these two are again independent events. So I'm going to find the total number of favorable outcomes by multiplying 5 and 7. So that's 35. So the probability of an owl flying C1 to C2 and C2 to C1, that is equal to number of favorable outcomes, the total possible number of favorable outcomes by total number of outcomes, 35 divided by 420. We'll keep it as it is, okay? Because I'm just guessing there could be some other value because we have just done case 1. There could be another value from case 2 and we might have to add these two. So I'm waiting for case 2 to happen. So case 2, what happens? We are going to find the probability of owl staying in cage 1 itself. For that to happen, the number of total sample space is not going to change. It is the same 420. So I'm not going to change that. It is the same 2 birds flying from cage 1 to cage 2 out of total 6 birds and 2 out of 8 birds flying C2 to C1. So it is going to be the same number as of the previous case. So 420, this is not going to change. What is going to change? The number of favorable outcomes is going to change. So I'm again going to consider that N of F for C1 to C2. So since owl is staying in cage 1 itself, the 2 birds that fly are going to be both parrots. So I'm going to consider this as 6C2 for cage 1 to cage 2. I'm not considering it as cage 1, not back and forth, only from C1 to C2. And N of F for C2 to C1. Now that there are 8 birds in cage 2, 2 birds are going to fly back. So these 2 birds again are going to be parrots because the owl did not fly at all from the first cage. I made a mistake. So since there are only 5 parrots in the first cage, it has to be 5C2. And when the other cage has eight birds, all of them are going to be parrots. That is why it is 8C2. Whereas in the previous case, I had taken 7C1 because if you remember, one owl flew and out of the 8 birds, 7 are going to be parrots and 1 is owl. So that is why I had taken 7C1 in the previous case. Whereas in this case, all 8 are parrots and so it could be any 2 parrots flying back to C1. So I'm considering it as 8C2. And I'm multiplying because again C1, C2, C2 to C1, they're independent events. So the total number of favorable outcomes is the product of these two. So 5C2 into 8C2. So the answer will be 5 into 4 divided by 1 into 2 times 8 into 7 divided by 1 into 2. I'm going to multiply, I'm going to cancel 2 and 2 and 4. So that will be what? 5 into 8 is 40. 40 and 7 is 280. So this is the total sample space. The required probability for the second case, which is owl remains in cage 1. That is equal to 280 over 420. So as I guessed, the total sample space is same, and the numerators can now be added, and I hope it gets simplified because as I can see, 7 is a common multiple in 35 and 280. There could be more common factors. We'll see. So the required total probability is equal to case 1 plus case 2. The probabilities of these two added together is 35 plus 280 divided by 420. So that will be equal to 315 divided by 420. So this probability, if you simplify using 7 multiples, this is what? 7 into 45. And this is 7 into 60. So 45 out of 60 is what? 3 by 4. The total required probability is 3 by 4. Now, coming to the second question, when two birds flew from cage 1 to cage 2 and two birds fly back from cage 2 to cage 1, the owl is still seen in cage 1. So that was the question in first subdivision. What is the probability that one parrot and the owl flew from cage 1 to cage 2? So here we are discussing the probability where the owl flew from cage 1. So which means if you look at the first subdivision, that question was based on addition theorem of probability. That's because there are like two scenarios, two cases rather. So this is case 1 where owl flies. The case 2 is where the owl stays, correct? And we are adding the probabilities of each case. So that is why this is an addition theorem of probability. This is like a question from addition theorem. Whereas the next question is a question from Bayes' theorem of probability. That's because we are handpicking one particular case, the case where owl along with parrot flies from cage 1 to cage 2. So we are going to ignore that particular case where it stays in cage 1 itself. So like this question should be solved in this way. The probability of owl flying from cage 1 to cage 2. That is equal to, given that, there is one more condition, given that owl flies back and forth from cage 1 to cage 2. So this is equal to, this is plain conditional probability. As we all know, Bayes' theorem is again conditional probability. It's an extension of conditional probability. So this is probability of owl flying from C1 to C2 and owl flies back and forth between C1 and C2, the whole divided by probability of owl flying from C1 to C2. I've written it in the form of a conditional probability, a regular conditional probability question. So this we have seen, there are two cases in probability of owl flying from C1 to C2 and C2 to C1. The two cases are 35 divided by 420 plus 280 divided by 420. So the first one, this case is where owl flies from C1 to C2. This is the case where owl does not fly from C1 to C2. So what happens? One of these goes to the top. So in Bayes' theorem, that's what happens. Once you fix the denominator, once the denominator is ready, you take one of the components to the numerator. So here we take case 1 to the numerator. So it is 335 divided by 420. So the answer will be, I'm going to divide it by 420 on top, on bottom. So 35 divided by 35 plus 280. So the answer will be 35 divided by 319. So that's, I'm sorry, 315. So this will be 1 divided by 9. That is the required probability of owl flying from C1 to C2, given that owl flies from C1 to C2 and from C2 to C1.